Hello and welcome. Today we are mastering the backbone of data ingestion in Snowflake, stages. We will design, build, and troubleshoot continuous pipelines, specifically focusing on how stages act as the critical integration point for your data. Let's start by defining what a stage actually is in the context of a pipeline. Think of a stage as a secure loading dock for your data warehouse. Data doesn't just teleport into tables, it must first arrive at a stage. We use stages to decouple the extract phase from the load phase. This is crucial because it allows your data sources to generate files at their own pace, while Snowflake ingests them efficiently in batches or microbatches. Whether you are doing massive bulk loads or streaming events, the stage is your mandatory starting point. This diagram illustrates the fundamental flow. On the left, we have your data sources generating raw files. These flow directly into the central node, the stage. This is where files reside temporarily. From the stage, we execute a command, typically copy into, to move that data into the target table on the right. This visualizes the stage as the critical bridge connecting your raw external data to your structured Snowflake tables. You have two primary choices when configuring a stage. First, internal stages are fully managed by Snowflake. These are great for user-specific files or quick testing using the table stage. However, for robust, continuous production pipelines, you will almost always use external stages. These point to your own cloud storage buckets like S3 or Azure Blob. This is vital because it gives you control over the data lifecycle outside of Snowflake, allowing other tools to access the raw data before it's even loaded. Here is the hierarchy of stage types you can choose from. At the core are Snowflake stages. Branching up, we have internal stages, the user stage for personal files, the table stage tied to specific tables, and named stages for general use. Branching down, we see external stages. These connect to the major cloud providers: Amazon S3, Azure, and Google Cloud Storage. Selecting the right branch depends on whether you need Snowflake to manage the storage or if you want to integrate with your existing cloud infrastructure. Designing a secure pipeline starts with the storage integration object. Never hardcode credentials like AWS access keys into your scripts. Instead, create a storage integration to handle authentication securely via IAM roles. Next, define a file format object. This tells Snowflake exactly how to read your CSV or JSON files so you don't have to repeat settings. Finally, enable directory tables on your stage. This acts like a file catalog, drastically speeding up file listing operations, which is a game changer for performance. This diagram shows the dependencies for a robust stage design. The storage integration entity is connected to the external stage, providing security. The file format entity connects to the stage to define the data structure. Finally, the stage is linked to a directory table. This relationship is crucial because the directory table indexes the files on the stage, allowing for fast retrieval and query performance. Now let's automate. We use Snowpipe for continuous loading. Unlike a scheduled bulk load, Snowpipe listens for event notifications directly from your cloud storage. As soon as a file lands in your S3 bucket, a notification is sent to Snowflake. The pipe object, which wraps your copy command, sees this event and queues the file for ingestion. This moves you from a batch mindset to a near real-time streaming mindset, ensuring data is available for analytics almost instantly. Follow the sequence of a continuous load. First, a file lands in cloud storage. This triggers a file-created notification sent to the event queue. Snowpipe picks up this trigger immediately. It then reads the file back from cloud storage and loads the data into the target table. This entire sequence happens automatically, ensuring your data pipeline runs continuously without manual intervention. You don't always want to load raw data exactly as is. You can transform it right at the stage level. Inside your pipe definition, instead of just saying copy into table, you can write copy into table from select. This allows you to cast data types, reorder columns, or parse JSON using parse JSON before it ever hits the table. It is efficient because it leverages the compute used for loading to do light transformation, saving you a step later on. This flowchart visualizes transformation during ingestion. We start with a raw JSON file at the top. It passes through transformation logic defined in your copy statement. We split the data. One path parses JSON into a variant column, another casts a field to an integer, and a third extracts a substring. All these transformed streams converge to populate the final table, ensuring clean data lands in your warehouse. Even the best pipelines break. When they do, troubleshooting is key. If a load fails, use validation mode to simulate the load and return specific error messages without changing your data. For history, check the copy history view. Crucially, optimize your file sizes. Tiny files cause overhead, huge files reduce parallelism. Aim for 100 to 250 megabytes. Finally, configure your on-error settings to decide if a single bad row should stop the whole pipe or just be skipped. This state diagram guides your troubleshooting process. Start by checking the status. If it's okay, the pipe is running. If there's an error, the pipe is stalled. From there, move to check history to find the specific file, then run validation mode on that file to isolate the exact error. Once identified, fix the file, and finally, retry the load to return to a healthy state.